There was also another optimization that was introduced as part of the Reno, is so-called the fast recovery. So remember, the last time I talked about fast retransmit. And fast retransmit is simply meant you detect the loss using 3 duplicate acknowledgements, and you retransmit that packet, and kind of the process continues. Fast recovery is a little bit different strategy, and it applies specifically to congestion avoidance. So the objective, when you detect the kind of loss using 3 duplicate acknowledgement, you want to decrease your congestion window in half, but still keep sending the packets kind of half of the congestion window, but you still want to send them out. For that, it's actually a very interesting way to do, because you send out batch of, for example, in this case, you send out batch of 8, and you have to know when exactly you're allowed to send more, because until you retransmit everything, until you get the acknowledgement, until you know that your packets that you're sending out actually being somehow in some form acknowledged or not acknowledged, but they're in flight, you have no idea. So for that part, you actually have to do some magic estimation. So what you can do, so one thing that you can do is to use received acknowledgements to indicate that some packet left the network. So you just know that those packets left the network, so you can potentially send something. There's a kind of a tricky mechanism that was introduced by kind of during this stage, is so-called inflation of the congestion window. So what you're trying to do when the loss detected, as shown in this picture, after you receive like 3 acknowledgement that acknowledging something previous. So you keep receiving this act 2, act 2, act 2. So what happens at that stage, you have your target window. So look, you had the window for 8, now you are having to 4. But you cannot send anything, because at this stage you basically you have no idea how many packets out there, like how many packets are outstanding. You know, like you sent out 8, potentially 1 you didn't, that was not received properly, and you know at this stage that the 3 more was definitely received, but you have no idea which ones, because TCP didn't tell you that. But what you're trying to do is simply to increase the window by this kind of inflate the window by this 3 duplicate packets or acts for the packets to get to the 7, and kind of keep this inflation until you have ability to send packets using the original window. It's still kind of, the target still will be 4, like if you follow this example a little bit more closely. But this inflation gives you ability to start sending packets before everything got recovered. So otherwise you will have to send recovered packet, wait maybe 1 RTT or several RTTs, and only then restart your batch. Like you effectively will waste some amount of time for the recovery part. In this case, you resend this number 2, but you still have ability to send more packets as some acknowledgements are coming back. And this is what exactly happens. So what you can see on this picture, so when you receive 3, you kind of have the window, you set the target of 4, you plus 3 because you receive 3 packets, so 7. So at this stage, it's still 7, still less than original 8, so you cannot do anything. You receive 1 more, you inflate to 8, which means still same as the old congestion window, so you cannot do anything beyond that. Now when you receive 2 more packets, you now increase the congestion window, or like inflated window, to 9 and 10 respectively, and you have ability to send 2 packets. So now you send in 11 and 12, and everything is fine. You still actually have in flight only 3 packets in this case. You're still not full 4 packets, but at least more than, because you don't know whether that original packet was transmitted, not transmitted. But effectively, as soon as you get all the acknowledgements for all the packets, now you can remove all this inflation part and start sending packets as normal. So I will recommend you to go over this example in a little bit more detail, maybe try to slightly a few examples like this afterwards. And this one just illustrating the same process, just in a slightly different picture. It's just what I'm trying to say is when you just sending data, you have this congestion window that is rolling among the sequence numbers. As soon as you detected loss, you set a target of congestion window to half, but then you start inflating it under assumption that each acknowledgement means that some packet left the network. And at some point, your inflated congestion window will go beyond the packets that you already sent out. So now you will be able to send a few more packets to keep packets flowing inside the network and not stop sending data at all. And as soon as the loss is recovered, you can effectively get back to the congestion window of half and just operate it on just a normal halved congestion window. So this one is Reno. There is actually a modification called New Reno. I'm not going to be talking about this, but that one is simply trying to optimize for the cases when there are multiple losses during the recovery process. So when you have one loss, it's will recover very easily because only one packet lost. If multiple, then this approach would unnecessarily potentially halve the window multiple times, even though the problem happened during the original batch of packets that was sent out.